All right. Okay. All right, so here, now you might be thinking, why do we care so much if events are independent or not? Well, it turns out to get the probability of two events occurring, it's a little bit easier if they're independent. Basically, if two events A and B, let's say, are independent, right? The probability of both of them occurring, that is the probability of event A and B occurring, it turns out to be just the product of the two. You just multiply the probabilities together. That's what we're saying here. So the probability of A and B, if they're independent, is equal to this product. So that's what's really nice about it, if they're independent. If they're not independent, that's a different story. You have to do a little bit more work. Not much more, you just have to do a little bit more. Okay? So here's another example. Let's suppose we decide to toss a coin into the air twice. Let's say we decide to do that, okay? What's the probability that the coin is going to land heads up both times, okay? We want to know what the probability is that the coin will land heads up both times. Well, again, it's really just like with the, with the die from the previous example, right? You're rolling the die twice. What's the probability of this number on the first die, on the first toss? The probability of another number on the second toss? It's the same thing with the coin. You're tossing the same coin twice. Each time, you know, the probability that the coin lands heads up is a half. In other words, the event should be independent. Intuitively, that makes sense. So what's the probability they both land heads up? That's a quarter. You know, you multiply these two together. Right? So again, since you're tossing the same coin twice, right? Each time, the probability of heads is a half. In other words, the events that the coin lands heads up on the first toss and the second toss, they are independent, okay? So that should happen. In fact, we can actually show that as well if we were to list the sample space, right? You know, the first H or T is heads or tails. We have the first toss here, as you can see. Here we have the second toss, right? So here we have heads on the first, heads on the second, heads on the first, tails on the second, tails on the first, heads on the second, tails on the first, tails on the first, tails on the second. I was right. But it's the same thing, right? You can see that the probability of getting heads on both tosses is a quarter. I'm just trying to illustrate that, yeah, that result should be true. I mean, here's not bad. You can list the sample space, but theoretically, you don't have to, which is nice. Any questions on this? Okay, let's keep going then. This is what we call conditional probability. This is actually what we're going to use if the events are not independent. So you can still get the probability of two events occurring. You can, if they're not independent. Here, however, you're going to need what we call conditional probability. This is really more of a notation thing for now, but if you want the probability of an event B occurring, given that the event A has occurred, that's represented by this. Here we're looking for the probability of event B given that event A has occurred. The probability of event B given that event A has occurred. I mean, if you go back to the previous example with tossing a coin and then and also rolling a die, the way we determine if the events were independent, we said, okay, well, suppose the event A did occur. That is, suppose the coin landed on heads. What would the probability of B be right? Remember how we did that? Let me see. Actually, let me go back to the slide quickly. Let me see if I can get there. Not there. Here. Remember how we said, okay, well, let's suppose event A did occur, right? Then what would the probability of B be? And then let's suppose the event did not occur. A did not occur. What would the probability of B then be? Here we were actually using conditional probability. I mean, I didn't write it out, but you could probably guess why. Weren't ready for it yet. But here we considered, what if A occurred? What if A did not occur? Right? And that's what you do with conditional probability. Here we go. That's what you do, remember, with conditional probability. So in a sense, we were working with this. So again, it looks like this. B, then a vertical line, then A. And from here, you can determine if two events are independent or not. That's actually what number 2 says here. Number 1, I just wanted to point it out in that it's not commutative in that this here may not be the same as this. I mean, could they be the same? That is possible, but doesn't have to happen though. Okay, this was over to the right. That was driving me nuts. So I just want to move it to the center, the title that is. Okay. So again, it's not commutative in that this here, the probability of B given A, it doesn't have to equal to the probability of A given B. So, I mean, they could equal each other, but they don't have to. We're not going to assume they're equal to each other, is what I'm saying. And also, again, you can use conditional probability to determine if two events are independent. And again, really, this is what we were doing in that earlier slide, even though I didn't write it down like this. I mean, if two events A and B are independent, what is this saying? The probability of A is the same, right? If B occurred or if B did not occur, this is the complement, right? So whether events A or B occurred, whether event B occurred or not, that should not affect the probability of A. Same thing over here, right? I mean, here in the top row, you're just basically interchanging the roles of A and B. But here, this is what we said, right? The probability of B is the same regardless if A occurred or if A did not occur. Right? Remember that little horizontal bar here is complement. Okay? So that, again, that doesn't affect. That is another way of determining if two events are independent or not. Okay, so we're going back to this example. Let's do conditional probability. And that's actually what we did as well, right? We did conditional probability here, right? So A is the event that the first marble is red. B is the event that the second marble is red. But again, we're not reaching back into the bag. And actually, we're out of time, so let me stop the recording.